Okay, so what we were looking at last time were these things that we wanted to do and the things that we wanted to avoid. And we had, sorry, it's all the dust and dander from the basement. We had looked at things that we wanted to avoid. So we had things like violation of ceteris paribus. Right. And we said, well, ceteris paribus basically says just keeping everything else constant, right? So when we're violating this guy, we're looking at more than one thing changing at a time. And we don't want to do that because we're wanting to tease out these different effects. And if we have more than one thing changing at a time, it's hard for us to know what's causing what change. The second one was this idea of bias, right? We didn't want to introduce bias. And we could introduce bias on purpose. We could introduce it accidentally. We could make it change the graphings of our scales or change the scales of our graphs. We could do all kinds of things like that, right, to introduce bias. This third one here is not defining your terms. So it's important that you talk about and you make sure that you define your terms because otherwise you might be talking about something completely different, right? I'm going to use profit and capital as an example. So capital, if you're a finance major, this is what? It's money. But to an economist, right, it's these manufactured aids that we have created to help us make stuff, right? It has nothing to do with money. Money is a little green piece of paper. It's basically a unit of accounting to keep track of who's got what, right? So these are these little manufactured aids. So if an economist and a finance guy are MUFAC, manufactured aids. If an economist and a finance guy are talking about capital, they're not even talking about the same thing, right? Another example would be profit. So when you hear the word profit, what do you think of? I mean, how do you define what a profit is? What is it? Yeah. Yeah, it's whatever's left over, right? Here's these costs that came out. I was making this stuff. Here's my cost. Here's what came in. This is what I've got, what's left over. So everyone has this idea. It's like, well, it's essentially the money left over, right, after you've made stuff. To an economist, though, I mean, we look at these costs. We look at things like, you know, the electric bill that people are paying and things like that. But there's another type of cost that we look at too. What's that cost? Opportunity costs, right? So when we're looking at costs, costs for us are explicit costs. These are the costs where you're actually paying out dollars, plus these implicit costs. Right, and these implicit costs are essentially opportunity costs. P-O-R-T-U-N. Right. So for the accountant and basically everyone else, they're looking at cost here. Oh, so for them, you know, profit. Just revenue minus costs. Well, everyone else, they stop here. Explicit cost. Oh, okay, I paid, you know, I've got a manufacturing plant and I've got $100 million in revenue coming in and I paid $50 million in wages and I paid $20 million for supplies and I paid $10 million for utilities. So I've got $20 million left over in my profit, right? And an economist would say, okay, well, you also have to account for the implicit costs, right? The opportunity cost of the resources that the firm actually owns as well. Right? So we want to make sure that we define our terms. We also have what's called the fallacy of composition. Right? So what the fallacy of composition says what's true for the individual is true for the group. All right. So if we look at an example from football, so if you go to a football game and you stand up, are you going to have a better view? Mm-hmm. If everybody stands up, will everybody have a better view? No. Or you could do, say, minimum wage, right? If we increase the minimum wage, and your hours don't get cut, are you going to be better off? Yeah, totally, right? Is everybody going to be better off? No. Some people are going to get their hours cut. Some people might not get hired in the first place. It's not that what is true for the individual is not true for the group. It's not that this can't be true sometimes. It is possible sometimes for what is true for the individual is going to be true for the group. The fallacy is in assuming that what is true for the individual is going to be true for the group. Okay. That's the fallacy. Fallacy just comes in where you're just assuming, well, if it's good for this person, it must be good for everybody. And it could be, but the fallacy is that when you're assuming that. Post hoc fallacy, right? This guy says correlation is causation. What do we mean by correlation? Exactly. So correlation here is when we have some relationship between two things. So we can either have a positive or a negative relationship, right? These two guys are correlated. They're moving together, right? Maybe that moving together is moving in the opposite direction, but they're moving together. What do we mean by causation?
Like something causing something else to happen.
Exactly. This guy says because these two things are moving together, because X and Y move together, X must be causing Y to move. And once again, it's not necessarily that that's not true. The fallacy is in assuming that it's true. Oftentimes there's something else that's going on. Let's look at, say, income and education. What's the correlation between these guys, or is there one?
The more education you have, the higher income will be.
Exactly. So usually these two guys move together, right? If one of these guys is going up, one of these other guys is going up as well, right? These guys are correlated, and they are heavily correlated. But is it this guy that causes this? Or is it this guy that causes this? Because in Mozambique, people are relatively poor. And education is a normal good, just like anything else. It's something that people buy. It's scarce, it has value. It takes resources to purchase it, right? They don't have a lot of income, therefore they can't buy education. The U.S. is relatively rich. We're not even sure if income and education causes each other or not. We honestly don't know if it's education that causes higher income or if it's the skill set that it takes to get an education that causes the higher income. You see what I'm saying? When you guys are all getting up here at 8 o'clock in the morning, you can pay attention, you can focus, you can work with others, you can do tasks. And at the end of 4 years, after having done that for like 40 different classes, you get this little piece of paper that says you're done, right? Is it the knowledge that you got, or is it the skill sets that you learned that it takes to get the diploma? You see what I'm saying? I mean, like I said, I'll use the example of my brother, who is a high school dropout. The guy just can't get his life together. He does not have a college education, nor could he get one. But that's because the basic skills that you need to get a degree, he does not have. I mean, he's a smart guy. He just can't do things like get up, show up to a place on time, and focus. Right? Those are the types of things that you need to get an education. So, is it being able to show up on time and focus that causes this? Or is it the education itself? Does Greek mythology actually make you earn more money? Or is it the fact that you can learn about Greek mythology that makes you earn more money? You see what I'm saying? And in fact, actually, interestingly enough, I mean, for the U.S., about 20% of people with a college degree will actually earn less than the typical high school grad. Right? So, I mean, there's no guarantee here. So, I mean, there's 20%, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Counting's hard today. 12, 13, 14, 15, 16, 17, 18, 19, 20. 46. 10% is 4.6, so 10 of you guys, statistically speaking, if you're here just for money, you're wasting your time. I don't know which 10 of you that is, all right? But 10 of you guys are wasting your time if you're only going to college for money. If you're going to college for other things, to better yourself, or to make new friends or experiences and all that kind of stuff, that's fine. Those things have value too. But if you're only going to college for more money, 10 of you guys are wasting your time. Right? So let's look at some graphing. And I know what you're thinking. We went over this in like 7th grade. Why are you going over this? I know all of this. You're wasting my time. Blah, blah, blah. And then, like 6 weeks later, these graphs are confusing. I don't understand the graphs. All right? So let me tell you something about the graphs. All right? Graphing in economics, it's like herpes. Okay? It's not going away. Okay? So on Friday night, if you guys go out and you meet some cute guy or some cute girl, and you had a little too much to drink, and you go home and they had herpes, guess what? Now you got herpes, and you got herpes for life. All right? It ain't going away. It's just the same thing here. The graphing's not going away. It's like herpes. We're stuck with it for the whole rest of the course. Okay? So don't think, well, I can ignore this part and I just won't have to worry about that part on the test, because it never goes away. Okay? So let's look here at some relationships. Because graphing, in essence, what it does is it allows us to visualize different relationships between two variables. So we've got an independent variable. We have a dependent variable. All right. And of course, when we talk about this independent variable, this is a guy that changes on his own. The dependent variable, his value depends upon the value of the independent variable. Okay. And then the independent variable is the guy that changes. So these relationships can be either positive, they can be negative, or they can be complex. So we can have a positive relationship, we can have a negative or inverse relationship, or it can be complex. Okay. So with this positive one, we know that when our independent increases, implies the dependent increases. All right. With our negative one, when our independent increases, our dependent decreases. All right. And then complex has both positive and negative. It has both positive and inverse components to it. Okay? So let's look at a very simple positive relationship here. Let's look at the relationship between number of beers consumed and blood alcohol content. Which one of these guys is the independent and which one of these guys is the dependent? Mm-hmm. And of course, typically we put the independent on the x-axis, so we're going to put our number of beers here. And we'll put our blood alcohol content here. Okay. And we have some relationship here. It kind of looks like this. All right, so here's 1, 2, 3, 4, 5, 6. I have no idea what these numbers are over here. I'm just making up numbers here. So maybe this guy right here is 0.06. This guy's 0.04. This guy's 0.02. Maybe this guy's 0.08. Bless you, 1.0. 1.2. I just made up numbers. Okay. So what we can do is we can connect these dots. And this helps us to know kinds of things too, right? Because now we know, okay, what happens if we drink 3.5, right? Or we drink 8 or whatever. We can extrapolate. So we have some function here, and I'll just call it our drunk function because that's in essence what it's telling us. And this guy tells us the relationship between the number of beers consumed and blood alcohol content. Right? It helps us to visualize this relationship. Oh, as we drink more beers, our blood alcohol content's increasing. It looks to me like every additional beer adds 0.02 to our blood alcohol content. And once again, like I said, I'm just making up numbers here. What's staying the same here? Well, the number of beers is changing. Okay. What else is staying the same? And let me put it to you like this. Here's our £190 guy. What would our function look like for a 110-pound woman? Would it look like that? No. Shifting in or rotating out? Doing this, right? Here's our 110-pound woman. All right? So for our 190-pound guy, 2 beers gets you a 0.04. For our 110-pound woman, she's at 0.08, all right? And for 1 beer, she's at, say, maybe 0.04. At 4 beers, she's at, I don't know, 1.6 or whatever, something like that, all right? 1.8, whatever. Everything else is staying the same. That's what ceteris paribus means. I mean, that's in essence when you're drawing graphs in any of your other classes, everything else is staying the same. The only thing that's changing is the number of beers, blood alcohol content, right? The number of people, their income. Whatever class it is that you're looking at, whatever graph it is that you're looking at, everything else is staying the same. What happens to this function if the guy hasn't eaten all day long? That function changes, right? What happens if it's a 190-pound guy, but one of the 190-pound guys is all muscle, one of the 190-pound guys is all fat? The function is going to be different, right? Everything else is staying the same. How fast they're being consumed, right? We don't have any time on here. Maybe it's 6 beers per day. 1 in the morning, second beer 2 hours later, third beer 2 hours later, fourth beer 2 hours later, fifth beer 2 hours later, sixth beer 2 hours later. What's the blood alcohol content? Nothing, right? So when we're drawing these functions, we're keeping everything else constant. Who the person is, how fast they're drinking them. I mean, everything else like that is staying the same. The only reason we leave this guy here in red is as a frame of reference so that we know that when we draw this guy here in blue, we know how much this thing is changing by, right? That's in essence what we're wanting to know when we're looking at these changes. How much is this guy changing by? Let's look at our negative or our inverse relationship. Let's look at sulfur dioxide emissions. Scrubbers. Okay, so here's our number of sulfur dioxide emissions and our numbers of scrubbers. Okay? So the power company right now is taking coal to burn in it. When they burn coal, it creates heat. That heat's used to boil water, turns into steam. Steam turns a turbine. Thanks to the properties of electromagnetism, as the turbine spins, it creates electricity. And they're shipping us electricity here so we can have the lights on. When you're burning the coal, though, it can create sulfur dioxide emissions depending upon the amount of sulfur that is in the coal. Which one is our independent, which one is our dependent variable? The scrubbers, what they do is they, in essence, take the sulfur dioxide emissions out of the smokestack. And scrubbers is their common vernacular name. Their true name is flue gas desulfurization processors. So which of these guys is independent, which of these guys is dependent?
Sulfur dioxide is independent and scrubbers are dependent.
Is that right? It's the other way around, right? So we're going to have the number of our scrubbers. And we're going to have our sulfur dioxide emissions. Okay? So if we have 0 scrubbers, we burn it and it just goes. I'm making up numbers here. I don't know what these numbers are. We're going to have 100 tons. Okay. Or 0. Here's at 0. If we have 1 scrubber, we'll have, say, 75. If we have 2, we'll have, say, 50 tons. If we have 3 scrubbers, we'll have, say, 25 tons. If we have 4 scrubbers, we'll have, say, 0. Okay? So here's our relationship. Once again, I just made up the numbers. And of course, we can connect these and we can see, oh, okay, how many scrubbers do I have in operation? You know, here's my emissions function. And we can see the relationship between the number of scrubbers that are going to be employed and the amount of sulfur dioxide emissions that we're going to have, right? And here we see this negative relationship. When the number of scrubbers increases, the sulfur dioxide emissions are going down, right? And so, for example, we see here at 2 scrubbers, we'll have 50 tons. And at 3 scrubbers, we'll have, say, 25 tons. All right? So when we employ these 3 scrubbers, this is what we get. All right? Stuff like that. What's being held constant?
The amount each scrubber scrubs,
Yeah, how big it is. How much power they're generating, the type of coal, right? Coal around the country has different levels of sulfur in it. All of that stuff is staying the same. And in fact, if we look at a map of the country, the U.S., right? A very bad map. This part right here, this is West Virginia, high sulfur content coal. Here's Montana. This is low sulfur coal, right? So it stands to reason that if you burn high sulfur coal, you're going to have more sulfur dioxide emissions from any level of coal than you would from burning the low sulfur coal, right? So if this is our emissions function for Montana coal, right? So here's our emissions function for low sulfur. And we switch from this type of coal to this type of coal, what happens to our function over here? Yeah, this guy shifts out, right? So if this is our low sulfur coal and we say, we're going to switch to the stuff from West Virginia, right? The guy does something like this. And so maybe with it, here's our high sulfur coal. Sorry. There's our high sulfur coal, right? And so we see here when we had 2 scrubbers, maybe now we get 75 tons. If we had 3 scrubbers employed, we get, say, 50 tons or whatever the number is. A couple of interesting things here. When they mix these sulfur dioxide emissions with water and a couple of other things, and what they actually wind up with is a form of gypsum. And what do you think gypsum's used for? People here in construction? Sheetrock, right? That's why when Lowe's was using a lot of their they had this Chinese drywall stuff. The Chinese drywall was made with really, really high sulfur coal. There was no, and people would put it up in their house, and the house would smell like rotten eggs after a couple of weeks. And they had to take all that coal, all that drywall out. Here's another thing that's really, really interesting. There's a couple of different ways. You want to reduce these sulfur dioxide emissions, right? I mean, obviously 25 is better than 100. There's a couple of different ways to do that. One way is to employ scrubbers. One way is to switch from, say, high sulfur coal to low sulfur coal, right? And interestingly enough, you have people that are like, say, for example, the United Mine Workers Union. And several other unions. They're all pressing this, the scrubbers, rather than switching coal content. Do you understand the problem? You can achieve the exact same solution a couple different ways, right? If you want to get to, say, 50 tons, you can get that way through having 2 scrubbers with low sulfur coal, or you can get that way with having 3 scrubbers using the high sulfur coal. The scrubbers are expensive. These things are not cheap. And the unions here are really, really big into the scrubber technology, not the switching coal. Why do you think that is? Why would they care? Yes.
So miners that mine the high sulfur content keep their jobs.
Yes. What about these guys here? Keep going. So if they switch to the scrubbers, it doesn't matter, right? If the government mandates you must use scrubbers, you have to use the scrubbers, all right? If the government just says, make sure your emissions are no more than 50 tons, we don't care how you do it. You could do that in a couple of different ways, right? Or you could have the government say you must use 3 scrubbers. Those are essentially the problem. So you could have this problem where they say, okay, no more than 50 tons, or you must use 3 scrubbers. All right? There's 2 different ways to achieve the solution. And therefore, the 3 scrubber solution, not the find the cheapest way to get to 50 tons. So it's about saving jobs, that's correct. But why would they not care about these people? These people here, when you think of a unionized mine worker, you got that picture in your head? That's these people right here. What about these guys? These guys are not unionized. So, if City Utilities switches from buying content, their coal from West Virginia and switches to Montana, it's the same coal worker, right? That hasn't changed. But we don't need these guys anymore. The union job disappears, the non-union job appears. And they don't want non-union jobs appearing because they're a union, right? So one way to do that is to say, we don't want this, and just do this, despite the fact that this guy costs more than this guy. This guy's cheaper. You get the same result. You get 50 tons of sulfur dioxide emissions. You can get that sulfur dioxide emissions cheaper by having 2 scrubbers in the low sulfur content coal rather than 3 scrubbers in the high sulfur content coal. The result is the same. This guy right here doesn't change, but one of these ways is cheaper than the other way. And so what you can do is you can go to your congressman and you can get legislation passed that says you must have 3 scrubbers. And then people say, no, we don't need 3 scrubbers. They say, oh, you don't care about the environment, you suck, right? It's like, no, we care about the environment, except that you can just get to the solution a whole lot cheaper if you do it this way than if you do it this other way. And the only reason they're interested in this other way is they're in essence just trying to protect their job. It has absolutely nothing to do with the environment. They could care less about the environment, right? It has to do with the fact that they want to maintain unionized coal jobs and not help create non-unionized coal jobs. Montana's interesting. You guys ever been out there? It is the Wild West. I am completely serious. They just recently outlawed drunk driving. Did you know that? I'm not joking. Bars are open. You can buy alcohol 24 hours a day, 7 days a week. Bars are open 24 hours a day. They never close. They just recently outlawed drunk driving. They're just like, well, I guess we've got to do something. We can't just have people driving, you know, completely plastered on the roads all the time. Like, you just do whatever you want to do. It's fascinating. It's a pretty country. Everyone's drunk. Alaska's the same way. Everybody's drunk. There's just nothing to do. There's nothing to do but drink. It's dark 6 months out of the year. What am I going to do? Drink. It's 40 degrees below zero. I'm not going outside. What can I do? Drink. We also have complex relationships. Complex relationships have both inverse and positive relationships to them, right? So we could have things like units produced, and we could have, say, average cost. And we can get some kind of relationship that, say, looks like this, right? So here's our, say, average cost function. I guess this should actually be money. And we see that we have a up to this output level, I'll just call it Q1. From output level 0 up to Q1, what type of relationship do we have? Negative, right? An inverse relationship. So here we have this negative or this inverse relationship. Right. Increases in output actually make average costs come down, and that's because of what are in essence called fixed costs. And from here to here, we have the exact opposite, right? We have, in essence, a positive relationship, right? We increase output, average costs actually begin to increase, right? Or we could have this guy doing the exact opposite. He could do something like this. We could have, say, units produced, and say profit, or once again, it just needs to be money. You can have some sort of profit function that kind of looks like this. All right. Where up until some output level, I'll call it Q2, because where this guy is 0 is not necessarily where this guy's positive, all the way up. Okay? It doesn't have to be that way. So up until 0 to Q2, what type of relationship do we have? From here to here. Positive, right? Here we see, oh, increases in output actually make profits go up, right? Then we reach some maximum, whatever this value is. We're going to say it's Q2. Increases in output beyond that guy, now we actually have a negative relationship, all right? An inverse relationship. Further increases in output actually make profits begin to fall. questions about graphing? Like I said, it's not going away.